Okay, the first step to solving this equation is factoring all of the denominators. So to begin with, 9x squared minus 1, you can think of that as 3x times 3x minus 1 squared. So that factors as the difference of squares, 3x plus 1 times 3x minus 1. So our first denominator factors like that. So let's replace that first denominator with its factorization here. So we have 3x plus 1 times 3x minus 1. Now looking at the second denominator, that looks like it might be the sum of two cubes, because 27x to the third power plus 1 can be thought of as 3x to the third power. 3x times 3x times 3x is indeed 27x cubed, plus 1 cubed. So you can think of this as the sum of cubes, and we can use the sum of cubes factorization formula. So 3x plus 1 times 3x times 3x is 9x squared, minus 3x times 1, which is 3x, plus 1 times 1, plus 1. Notice that this is the same factor as appears in the denominator on the right. So let's replace that middle term with that factorization. And I better give myself some more room here. Okay, so replacing this denominator with its factorization, we have 3x plus 1 times 9x squared minus 3x plus 1. 7 over that. So there's our equation with everything factored. Notice that this does not factor. We now know because in the sum of cubes factorization, this never factors. That will never factor. So this doesn't either. So we need to multiply now both sides of the equation by something that will cancel out all of those denominators, which must be this denominator. So everything in the whole equation times that. So we have 3x plus 1 times 9x squared minus 3x plus 1. And that gets multiplied times every one of these terms in the equation. It's actually being multiplied times both sides of the equation, and it distributes then to each term in the entire equation. So coming to the far left here, the 3x plus 1 cancels out. Oh, you know what? We need another factor, 3x minus 1. Times 3x minus 1, because we need to cancel the 3x minus 1 as well. So it's times this product of these three terms, factors. So the 3x minus 1 and the 3x plus 1 cancel out, and you're left with 3 times 9x squared minus 3x plus 1. Then plus. There, everything cancels. The 3x plus 1 cancels, and the 9x squared minus 3x plus 1 cancels. So you're left with 7 times that 3x minus 1 factor. And on the right side of the equal sign, you've got 4 times the 9x squared minus 3x plus 1 cancels, but you're left with 3x plus 1 times the 3x minus 1. Okay, now we got rid of the denominators, cancel out all the denominators. We'll have to distribute this 3 through the parentheses here, this 7 through the parentheses here, and let's FOIL out these first. Well, actually, it's a sum. It's a plus b times a minus b is a squared minus b squared again. So, okay, over here we have 27x squared minus 9x plus 3 plus 21x minus 7 equals 4 times 9x squared minus 1, using the difference of squares factorization. Okay, now combining like terms. Let's see, we have 27x squareds. Then we have a minus 9x and a plus 21x. So that's plus 12x. And then minus 7 plus 3 is minus 4. And on the right side, the 4 distributes. So we have 36x squared minus 4. Okay, now let's get everything on one side of the equal sign. Let's take 27x squared from both sides. And let's add 4 to both sides. And let's take 12x away from both sides. So the result of all that is a big 0 on the left side. And on the right side we've got 36 minus 27. Which is 9. 9x squared minus 12x. So now we can factor out a 3x times 3x minus 4. So we have two possible solutions here. This gives us x equals 0 as a possible solution, or this one gives us x equals 4/3 as a possible solution. X equals 0 does not make any of the original denominators equal 0, so it checks out okay. And x equal 4/3, that also doesn't cause us any problems. The only numbers that would be a problem here is if we found that our solution was either 1/3 or negative 1/3. But these are okay then. They're both valid solutions to this rational equation.